Good morning, dear students, and once again, welcome back to our course. Our objective is to prepare for GATE examination, and we are basically trying to understand the basic fundamental aspect related to network theory. And this course is very much important for both the branches, electrical as well as electronics and communication engineering students. And in the last lecture, we discussed in detail about the concept of phasor diagram. So let us try to make a quick revision on what exactly phasor diagram or what is the meaning of phasor. So phasor is basically what? It is a graphical representation of an alternating quantity through which we are in a position to represent its magnitude, its direction, as well as its sense of rotation. That means a phasor representation for an alternating quantity represents three basic fundamental aspects of an alternating quantity. First one is its magnitude, second one its direction, and third one its rotation. Now, when I say that through phasors we are in a position to represent the rotation of an alternating quantity, so the very next question that will come in our mind is that what will be the rotation, or what at what rate this phasor is going to rotate. And in the last lecture I told you that the sense of rotation and the speed at which the phasor is going to rotate, it depends upon the frequency of an alternating quantity. This is very important. That means every phasor is going to rotate normally in the anti-clockwise direction at a speed exactly going to be equal to the frequency of an alternating quantity. Now, what is frequency? Frequency means it is nothing but number of cycles per second done by that quantity. So, in the same way, suppose if we are trying to draw the phasor diagram for an alternating quantity as far as Indian scenarios are concerned. So in Indian scenario, we know that the frequency is going to be 50 hertz. So if you try to draw the phasor for these alternating quantity, the corresponding phasor is going to rotate in anti-clockwise direction at a speed of 50 cycles per second. That means the frequency of an alternating quantity and the corresponding phasors are going to rotate at the same pace. That is very important. And then through this phasor diagrams we are in a position to find out the uh, concept of, you can say, lead and lag. Now, what is lead means a quantity which is going to be ahead with respect to the reference value. जो पहले आती है, that is called as leading, and that is the sense leading is treated as positive or in the anti-clockwise sense. I told you that why to take anti-clockwise, why not to take clockwise. In the same way, lagging means negative. That means it is going to create some kind of delay, and we need to take the lagging quantity as a clockwise sense. This is very important. And then we also discussed, suppose if you have two alternating quantity represented by some kind of mathematical equations, then how to find out which one is lead and which one is lag. The thing is that first of all we need to plot the phasors of each quantity on the phasor diagram, and then the quantity which is appearing to be the most anti-clockwise sense, that is considered to be the leading one with respect to the previous one. For example, if you have the quantity like I1 equals to 10 into sine of say 50t plus 10 degree, and second one is I2 is equals to say 20 into sine of 50t then minus 30 degree, and our objective is to find out which one is going to be the leading one and which one is going to be the lagging one. So how to find out this? So first of all we need to draw the reference axis. So here, or you can say, first of all we need to find out or draw the corresponding structure to draw the phasor for this. So this is going to be the reference axis, and this axis is coinciding your 0 degree angle. Then here we have plus 90 degree angle. Then here we have plus 180 degree angle. Here we have plus 270-degree angle, and then coming back to 360, which is nothing but the reference value. And then we need to indicate these uh, alternating quantity corresponding to their phasors. So here I1 is 10 sine omega t plus theta, where omega t is 50t and theta is nothing but plus 10 degree. So plus means it is going to be a leading one. So this is going to be a leading one, leading with respect to the reference axis, which is nothing but 0-degree axis. So here I1, so this is the origin, and then here we need to indicate I1. So somewhere over here, this is going to be I1, and this is going to lead the reference. That's why it has to be indicated in the anti-clockwise sense by an angle of 10 degree. So this is going to be 10 degree or plus 10 degree. This is very important. And then we need to indicate I2. So I2 is 20, then sine of 50t minus of 30 degrees. So here this minus indicate that it is going to be a lagging. And I told you that lagging has to be indicated in clockwise sense. This is very important. So with respect to this reference axis or 0-degree axis, we need to indicate lag of 30 degree. So it has to be in clockwise sense. This is important. So this has to be in clockwise sense, and it is going to be minus 30 degree, and this is going to be I2. That is very important. The magnitude of this particular phasor is going to be equal to the peak value of this alternating quantity. So here I can write 10 ampere, which indicate the magnitude of this particular phasor, and here I can write 20 ampere, which indicate the magnitude of this particular alternating quantity at that instant. This is very important. And then our objective is to find out what is the phase difference between I1 and I2. That means which is going to lead and which is going to lag. Now from this diagram, it is very clear that I told you that the most anti-clockwise sense quantity is considered to be the leading quantity with respect to the previous one. So here if you consider I2 as a reference, now with respect to I2, I1 is available in the anti-clockwise sense. So hence it is very clear that I1 is going to lead I2. Now the next question will appear in mind, that what will the phase difference? That means by what angle I1 is going to lead I2. So you need to find out the phase difference between I1 and I2. So here we have 30 and then here we have 10. So total angle between I1 and I2 is going to be 10 plus 30. So this is going to be what? 40 degree. So I can write here I1 leads I2 by 40 degree. This is very, very important. I hope this is clear to everyone. In the same way, suppose if you take I1 as a reference, so with respect to I1, I2 is available. Let me change the color. Now see, if you take I1 as a reference, so with respect to I1, I2 is available in the clockwise sense. So I can write here as I2 lag I1 by 40 degree. Both the statements are exactly the same. The thing is that in one case we take I2 as a reference. So with respect to I2, I1 is appearing on the extreme anti-clockwise sense. That's why it is going to lead. That's why we can write here as I1 lead I2 by 40 degree. In the next case, we took I1 as a reference, and with respect to I1, I2 is available in the clockwise sense. And I told you that whenever we are dealing with clockwise, the quantity is going to be lag. Hence, we can write here as I2 going to lag I1 by an angle of 40 degree. This is very important. So these points we have discussed in the last class. Now, in today's class, first of all, we are going to continue with the particular topic. That means we are going to explore some more aspect related to phasor diagram, and we are going to find out what is the relationship between voltage and current in case of pure resistor, pure inductor, and pure capacitor. And then we are trying to find out the phasor diagrams for a very simple electrical circuits, and then we will try to solve some numerical that were asked in previous year gate as far as electrical and electronics and communication engineering students are concerned. And then we will discuss the very fundamental aspect related to three-phase circuit. So till now, whatever the circuits which we are discussed in AC domain, of network theory, by default all are nothing but single phase. So we will try to discuss what is three phase, and in three phase what are the possible connections through which we can connect the load. That means what is the meaning of star, what is the meaning of delta, and then in star what is the relationship between line voltage, phase voltage, line current, phase current. In the same way, suppose we connect the load in delta combination, then what will be the relationship between line quantities and the corresponding phase quantity. And at the same time we are trying to draw the phasor diagram for a three phase circuits. So let us try to understand them one by one. Now suppose if you have a pure resistor like this, let me indicate over here. Suppose if you have a resistor of value capital R, where capital R indicate its ohmic value, that is nothing but the resistance of this resistor, and through this resistor if you passed alternating quantity or alternating currents is small I, and let us consider that the magnitude of that I is indicated by the mathematical formula I max into sine of omega t. This is let equation number 1. So we have considered that we have a resistor, and through that resistor we are going to pass a small value of an alternating current indicated by equation number 1, I equals to I max sine of omega t. And we know that according to Ohm's law, the moment we pass some finite value of current through a resistor, we are going to experience a voltage. And because the sense of that current is alternating, so whatever the kind of voltage which we are going to experience across that resistor, it is again going to be an alternating. So if you are trying to find out what will be the expression for that voltage and what will be the relationship between that voltage with respect to current, whether they are in phase with each other, or current is going to lead with respect to voltage, or voltage is going to lead with respect to current, that we need to find out. And at the last we need to draw the phasor diagram for a pure resistor. That means what is the relationship between V and I if you are dealing with a pure resistor. So let us try to fulfill our objective. So if you apply Ohm's law over here, apply Ohm's law over here, we can write small v, where small v indicate the instantaneous value of voltage which is going to be appear across this resistor. So this is going to be plus for a movement, and this is going to be minus for a movement, and this is going to be small v. So we are going to write what is the expression for this v. So according to Ohm's law, we can write this small v is going to be equals to small I into small r. Now from equation 1, what is small I? It is nothing but I max into sine of omega t, then multiplied by r. Or if you club this I max with respect to this r, I can write here as I max into r multiplied by sine of omega t. Or I can write this equation as small v is going to be equals to V max into sine of omega t. Let this will be your equation number 2. Now from equation 1 and equation number 2, let us try to find out which quantity is going to lead, which quantity is going to lag. Now equation number 1 is nothing but the value of current or instantaneous value of current flowing through resistor, and the expression is I equals to I max sine of omega t. And equation number 2 indicate that the instantaneous value of voltage that is going to be appear across this resistor capital R, and it is Vm sine of omega t. Now from equation number 1 and equation number 2, it is very clear that both the alternating quantity, that means this current and this voltage, they are exactly coinciding each other. That means there is no phase difference between them. See, I1 is I max into sine of omega t. So here we don't have any phase difference. In the same way, V is going to be V max sine of omega t. Here also we don't have any phase difference. That means in case of pure resistor, voltage and current are in phase. This is very important. That means they are not going to have any kind of phase difference. That means the meaning is that the moment we applied a voltage across the resistor, at the same instant there will be a flow of current through that particular resistor. Or the moment we try to pass a current through a resistor, at the same moment we are going to experience a voltage across that particular resistor. That means this voltage and current are exactly in phase with each other. कहने का मतलब ऐसा है कि अगर आपके पास में एक रेजिस्टर है और वो रेजिस्टर के अक्रॉस में से आप कुछ फाइनाइट वैल्यू ऑफ करंट पास कर रहे हो, तो द मोमेंट यू पास दैट करंट, एट द सेम इंस्टेंट वी आर गोइंग टू एक्सपीरियंस अ वोल्टेज विदाउट एनी डिले. जिस पर्टिकुलर टाइम पे आपने करंट पास किया, उसी पर्टिकुलर टाइम पे उस रेजिस्टर के अक्रॉस में आपको वोल्टेज दिखने लग जाएगा. In the same way, suppose if you have a resistor and the moment you apply voltage across that particular resistor, the very same instant we are going to experience a current through that particular resistor. That means they are not going to have any delay or any what we can say lag with respect to each other. They are exactly coinciding with each other. That means in case of pure resistor, voltage and currents are going to be in phase with each other. This is very important. Why? Because if you compare equation number 1 and equation number 2, here we don't have the concept of delay. That is very important. Or here we don't have the concept of any phase difference. Now suppose if you want to draw this on the phasor diagram, so how to draw this? So first of all we need to create a structure, and then on structure we need to indicate a reference axis. So this is going to be the reference axis. So here this is going to be 0 degree, this is going to be 90, this is going to be plus 180 degree, and this is going to be plus 270 degree. So this is going to be plus 270 degree. So this is plus 270 degree, and then coming back to plus 360 degree. Now let us try to indicate these quantities simultaneously. So first we have a current I. So because it has no phase shift with respect to reference axis, see here we don't have the concept of theta. Plus theta is going to be 0. That means this is going to be on the 0 reference axis. So somewhere over here this indicate the phasor for current, and this is going to be I max. This is very important. And then we need to draw the phasors for voltage. Now see here, this is Vm, and from this equation Vm is going to be equals to what? Im into R. Now if you consider that the value of this R is more than 1, then in that case the value of this Vm is always more than Im. Now based on this particular concept, I'm going to draw this Vm. Now again from equation number 2, here we don't have any theta. Theta is going to be 0. That means it is going to again coincide with respect to the reference axis. So this is going to be your Vm again over here. So this is going to be Vm. Now from this graph it is very clear that Vm and Im are exactly in phase with each other. This is very important, and this is the case for pure resistor only. Pure resistor only. So in this way we can draw the phasor diagram for pure resistor. This is very important. Now why we are learning this? The thing is that we want to draw the phasor diagram for any electrical circuit, and I told you that as far as electrical engineering domains are concerned, most of the electrical circuits are made up of 3 fundamental elements. First one is resistor, second one is inductor, and third one is capacitor. And if you know the phasor diagram for each one of them individually, then it is very easy to find out the phasor diagram for any circuit which are made by all these 3 elements. That is the reason we are discussing the phasor diagrams for individual circuit element. For example, what is the relationship between voltage and current in case of pure resistor, then in case of pure inductor, and then in case of pure capacitor. So first point is clear, and we have done a discussion on this, that in case of pure resistor, voltage and current are exactly in phase with each other. That means the moment we switch on the supply, That means the moment we apply a voltage across a resistor, at the same moment we will experience a current without any delay. In the same way, if you try to pass a current through a resistor, the very same moment we are going to experience a voltage across that particular resistor. Hence, if you try to draw the phasor for pure resistor, the voltage and the current are exactly coinciding with each other, because the value of theta, or you can say theta phase difference, in this case is going to be 0 degree. This is very important. Now let us try to discuss what will be the phasor diagram for pure inductor. In case of pure inductor, what is going to be there? Now again we need to take and apply the same logic. Suppose we have an inductor like this, having an inductance value of capital L, and through this inductor we are going to supply some current, and let us consider that the expression for this current is again Im into sine of omega t. Let this will be your equation number 1. And the moment we pass this current through this inductor, we are going to experience a voltage, and the equation for that voltage is going to be V equals to what? L di by dt. Now our objective is to find the expression for this V, small v. So what we need to do, we need to put the value of that I in this equation. So it is going to be L d by dt of I. So I is going to be Im into sine of omega t. This is very important. So I can write here as L. I'm going to take common derivative of sine. It is going to be what? Cos of omega t into omega. Or I can write here as L into Im into omega. This is very important. Into cos of omega t. Or I can write here as V is equals to, this entire term is going to be V max, and then cos of omega t I can write here as sine of omega t plus 90 degree. That this will be your equation number 2. This is very, very important. And now let us try to compare these equations and try to find out what is going to be what is happening in case of pure inductor over here. Now see, equation number 1 indicate the value of current flowing through this inductor, and it is I equals to I max into sine of omega t. And now equation number 2 indicate the voltage which we are going to experience across this particular inductor, and it is Vm into sine of omega t plus 90 degree. Now here, with respect to this current I, the voltage is going to lead by an angle of 90 degree. So in case of pure inductor, one thing is very clear, that voltage leads the current by an angle of exactly 90 degree. This is very important. Or you can also define this statement as current lag voltage by an angle of 90 degree. Both are the same thing. वोल्टेज लीड कर रहा है 90 डिग्री से, इसी का मतलब है कि करंट लैग कर रहा है 90 डिग्री से. This is very important. And the next thing is, let us try to see the expression for this Vm. So I can write here as Vm is going to be equals to L into Im into omega. Now suppose if you are interested to find out what will be the ohmic opposition offered by this inductor to the flow of this current through it, so I am going to represent that by XL. Now XL is going to be the ohmic opposition offered by inductor to the flow of current through it, and according to Ohm's law, the ohmic opposition is simply the ratio of voltage by current. So here this is going to be Vm divided by current is going to be Im. Now what is Vm? Vm is L into Im into omega divided by what is Im? It is simply Im. So this Im will get cancelled, and here we got the value as omega into L. So I am writing here as XL is going to be equals to what? Omega into L. Now this XL is known as inductive reactance. Inductive reactance. This is very important. So what is inductive reactance? Inductive reactance is simply the ohmic opposition offered by an inductor to the flow of current through it, or to the flow of alternating current through it. And the expression for XL is nothing but omega L. Or we can write this as, because omega is angular frequency, and we know that omega we can write in terms of normal frequency or in terms of time period. So I can write this equation as omega L. So omega I can write as 2 pi f. So 2 pi f into L indicate your XL, or I can write this as 2 pi divided by capital T into L. Both are nothing but the same thing. So this is very important. So inductive reactance, the formula is omega L, and in case of pure inductor, voltage lead the current by an angle of 90 degree, or current lag voltage by an angle of 90 degree. Now the same thing, suppose if you want to draw in terms of phasor. So how to draw that? See here. This is going to be the structure, and this is going to be the reference axis. So this is reference axis. So this is 0 degree, and then here we have plus 90 degree, here we have plus 180 degree, and here we have plus 270 degree, and so on. Now let us try to indicate these phasors on the phasor diagram one by one. So first phasor we need to draw for I, and I is going to be Im sine of omega t. So here we don't have theta, that's why it is going to be coincide with the reference zero axis. So here this is going to be I. This is going to be I. So here we have Im, which is going to exactly coinciding the reference axis or 0 degree axis. Now let us try to indicate V. So here from equation number 2 it is very clear that here we have plus 90. Plus means leading. Leading means we need to indicate them in anti-clockwise, because see here we have plus 90. So on this particular axis we need to indicate voltage. So this voltage is going to lead the current. So this is going to be the voltage. This is going to be Vm. So voltage is going to lead the current by exactly 90 degree. So this is what the phasor diagram for pure inductor. The same thing we can draw like this. Suppose if you take the voltage on the reference axis like this. So instead of taking current on the reference axis, 0, 90, plus 180, and then plus 270. So this plus 270 I can write as minus 90. Both are nothing but the same thing. And here we have 360 degree. Now suppose if you take voltage on the reference axis. So if you take voltage on the reference axis, it is going to be on 0 axis. So this is voltage phasor. That is nothing but Vm. And I told you that with respect to this, current is going to lag by an angle of 90 degree. So lagging means we need to indicate that in clockwise sense. So minus 90 is going to be there. So somewhere over here we are going to have the phasor for current. So this is going to be Im, and from here it is very clear that the current is going to lag the voltage by an angle of 90 degree. That's why we need to indicate them in clockwise. Now I think it is very clear why we need to take the leading quantity in the anti-clockwise and why need to take lagging quantity in the clockwise. This is very important. So these points you have to remember, that in case of pure inductor, voltage and current are not exactly coinciding with each other. In case of pure inductor, voltage is going to lead the current by an angle of 90 degree, or current is going to lag voltage by an angle of 90 degree. Both are the same thing. And second important thing is that the ohmic opposition offered by an inductor to the flow of current through it. That means the formula for inductive reactance, and the formula is omega L, or 2 pi Fl. or 2 pi by t into L, where F indicate the frequency in hertz, capital T indicate the time period in second, and L indicate the inductance of that inductor, which is in Henry. This is very important. Now let us try to discuss what is going to be there in case of pure capacitor. Pure capacitor. Now again, in order to find out the relationship between the voltage and the current in case of pure capacitor, again we need to apply the same topology. And the topology is, let us consider that we are having a capacitor like this, and to this capacitor C, we are going to apply a voltage small v. Okay, so first of all, let us try to write the equation for this voltage. Let us consider that this voltage indicated by symbol v, small v, and it is going to be Vm into sine of omega t. That this will be our equation number 1. And the moment we have this voltage which we applied across this capacitor, it is trying to flow some finite value of current through this capacitor, and we know that the equation of that capacitor is going to be, the equation for the current flowing through this capacitor is going to be I equals to C, where C indicate the capacitance, into dV by dt. I equals to C dV by dt. Now from equation 1, what is small v? It is nothing but V max into sine of omega t. So I can write here as I is going to be equals to C d by dt of V. So it is going to be V max into sine of omega t. Or I can write here as capital C into Vm, derivative of sine, it is going to be cos of omega t into omega. Or I can write here as C into Vm into omega. Instead of writing cos omega t, I can write this as sine of omega t plus 90 degree. This is going to be what I. Or I can further modify this equation like this C into Vm into omega. I can write this as Im. So the equation is I into Im into sine of omega t plus 90 degree. This will be your equation number 2. Now, if you compare equation 1 and 2, what we can conclude? Now here, equation 1 indicate the instantaneous value of voltage which we have applied across capacitor, and the expression is V equals to Vm sine omega t. Here we don't have theta, so theta is going to be 0. That means this is going to be on the reference axis. Now with respect to this voltage, if you see equation number 2, here we have plus 90. Plus indicate lead. That means in case of pure capacitor, current lead voltage by an angle of 90 degree. This is very important. So I can write here as, in case of pure capacitor, current I lead voltage, that is V, by an angle of 90 degree. This is very important. Or the same statement we can write, current lead voltage by 90 degree. It means that voltage lag current by 90 degree. This is very important. So here this is lead, that's why we need to take plus, that means in anti-clockwise. This is lag, that's why we need to take minus, that is clockwise. This is very important. So these points you have to remember, that in case of pure capacitor, current lead voltage by an angle of 90, or voltage lag current by an angle of 90. Now let us try to find out the ohmic opposition offered by capacitor to the flow of current through it. That means to the flow of alternating current through it. And to find out, again here we need to apply Ohm's law. So we can write here as the ohmic opposition offered by capacitor is indicated by symbol omega c, and it is going to be equals to what? Vm divided by Im. Now this is going to be Vm whole divided by, what is the expression for Im? Im is going to be equals to omega into Vm into C. So I can write here as omega into C into Vm. Now this Vm will get cancelled. So I can write here as omega c is going to be equals to, or instead of indicating this by omega c, let us consider that it is indicated by symbol xc, because previously we indicate ohmic opposition offered by inductor as xl. So let us try to indicate this as xc, where xc indicate the ohmic opposition offered by capacitor. So this is going to be xc. Instead of writing omega c, let us write this as xc. So xc is going to be equals to 1 upon omega c. This is very important. Or we can write this as 1 upon omega is 2 pi f into c. Or if you replace this f by t, so it is going to be t divided by 2 pi into c. So this is very important, xc. And this xc is called as, in case of inductor, that is called as inductive reactance. Now in case of capacitor, this is called as capacitive reactance. Capacitive reactance. This is very, very important. Capacitive reactance. So x is going to be 1 upon 2 pi fc, or 1 upon omega c. This is very important. Now you have to remember this. In case of pure capacitor, current lead voltage by 90, or voltage lag current by 90, and the expression for the capacitive reactance, that is nothing but 1 upon 2 pi fc, or 1 upon omega c, or t by 2 pi c. Now let us try to indicate these relationships on the phasor diagram. So here we first need to draw the structure, and then on that structure indicate the reference. So here 0 degree, this indicate the reference axis. Then here we have plus 90, and then here we have plus 180 degree, and here we have plus 270 degree, and then coming back to 360 degree. Now first we are going to indicate the voltage, because voltage is Vm sine omega t without any delay. That means it is on the reference axis. So somewhere over here we have voltage. This indicate the voltage. This indicate the voltage, that is nothing but Vm, which is going to be on 0 degree. Now from this statement it is very clear that current lead voltage by 90 degree, or you can see the same from equation number 2, that in equation number 2 we have the expression for instantaneous value of current, and it is sine of omega t plus 90. Plus means lead, and by an angle of 90 degree. So here we have plus 90. So on this axis we need to indicate the current. So this is going to be the current. On this axis we are supposed to have a current. So this indicate current phasor, that is nothing but Im, which is going to lead the voltage by an angle of plus 90 degree. This is very important. Or suppose if you take current as a reference, then what will happen? Again the same. Instead of taking leading, we need to take lag, because in case of pure capacitor, voltage lag current by an angle of 90 degree. So this is going to be the 0 degree, that is reference. This is going to be plus 90. This is going to be plus 180. This is going to be plus 270, or I can write here as minus 90, which are nothing but the same thing, and then coming back to 360. Now suppose if you indicate current on the reference axis, if you take the expression for current as I equals to something which is nothing but Im into sine of omega t, then with respect to that, this V is going to be Vm into sine of omega t minus 90. That means with respect to current, voltage is going to lag. That is very important. So here I'm going to represent first the current. So this is going to be the current axis, that is nothing but Im. So with respect to Im, voltage is going to lag. So it is going to lag by 90. So lagging means clockwise. So it has to be on 90 on this axis, downward direction. So this indicate the voltage, that is nothing but Vm, and it lag the current by an angle of exactly 90 degree. This is very important. So these points you have to remember, that In case of pure capacitor, current lead voltage by an angle of 90, or voltage lag current by an angle of 90. And what is the expression for this ohmic opposition offered by capacitor to the flow of current through it? And it is going to be capacitive reactance, and the expression is xc, which is going to be 1 upon omega c, where omega is 2 pi f. So I can write here as 1 upon 2 pi fc, or you can write that as capital T by 2 pi into c. So finally, what we conclude, in case of pure resistor, voltage and current are in phase. In case of pure inductor, I can write here as, in case of pure inductor, voltage lead current by 90 degree, or current lag voltage by 90 degree. And the ohmic opposition offered by inductor to the flow of alternating current through it, that means to the flow of small I through it, is nothing but XL, which is also called as inductive reactance. And the expression for this is XL is going to be equals to omega into L, or simply 2 pi f L, or you can write this as 2 pi by capital T into L. They are nothing but the same thing. And then in case of pure capacitor, we conclude that current lead voltage by 90 degree, or you can write here as voltage lag current by 90 degree. This is very important. And then in case of pure capacitor, the ohmic opposition offered to the flow of current through it is nothing but xc. This is called as capacitive reactance, and the formula is 1 upon omega c, or you can write here as 1 upon 2 pi fc, or it is capital T divided by 2 pi c. This is very important. And then the corresponding phasors. So we can write, like in case of resistor, the voltage and the current are exactly in phase with each other. In case of inductor, suppose if you take um, voltage on the reference axis, so this is going to be V. So with respect to V, current is going to you can say lag. So I can write here as, in case of inductor, current lag the voltage. So lagging means clock. So here we need to indicate current lagging by an angle of 90 degree. In the same way, in case of pure capacitor, suppose if you take voltage on the reference axis, so with respect to this, current is going to lead. So current lead voltage by 90 degree. So it has to be over here. This is going to be I leading by 90 degree. So here we have lagging concept. So current lag voltage by 90, and here in case of capacitor, current lead voltage by 90. But in case of pure resistor, current and voltage are exactly in phase. That means there is no phase difference, or you can say phase difference is going to be 0 degree. Here we have 90, and again here we have 90. This is very important, and this you have to remember. That is very, very important. Based on this, let's try to solve some numerical that were asked in previous year GATE. And the statement for this is, here we have two set of mathematical equations of an alternating quantity. First one is V1, which is going to be equals to minus 10 into cos of omega t plus 50 degree. And second one is V2, which is going to be equals to plus 12 into sine of omega t minus 10 degree. and our objective is to find the phase difference between V1 and V2. So here we have two objectives. First objective is we need to find out which one is going to lead the other quantity, or which one is going to lag the other quantity. That we need to find out. That means which is going to lead, that is considered. And then second is by what angle, that means what is the phase difference. These two we need to find out. That means आपके पास में दो सेट ऑफ मैथमेटिकल इक्वेशंस है. एक v1 है, that is -10 cos omega t plus 50, and v2 है +12 sin of omega t minus 10. एंड योर ऑब्जेक्टिव है कि इन दोनों में से कौन किसको लीड कर रहा है, और दूसरा ऑब्जेक्टिव है कि कितने एंगल से लीड कर रहा है, व्हाट एंगल, which quantity is going to lead the other quantity. That we need to find out. Now, how to solve this numerical? It is very simple, but at the same time quite tricky. And these kind of questions were asked normally in GATE for 1 mark. You have a set of mathematical equations, and your objective is to find which is the extreme most leading quantity and which is going to be the extreme most lagging quantity, and what will be the phase difference between any two of them. So how to solve this? So this we can solve directly by applying the concept of phasor diagram. And one thing you have to see over here is that the V1 quantity we define in terms of cos, but V2 quantity we define this in terms of sine. First thing. Second thing is that if you see the frequency, both are rotating at the same frequency, or both are varying at the same frequency. See, here we have omega, and same omega is available over here. So this technique is applicable when and only when we have a pair of two or more than two alternating quantity, both are varying at the same frequency. This is very important. So here, because both the quantities are varying at the same frequency, omega omega, that's why we can apply this technique. The thing is that one is in sine and another one is in cos. So what we need to do, either you convert this sine into cos and then plot them on the phasor diagram, and then find out which one is the most leading, or which one is available at the extreme anti-clockwise sense, that you can treat as a leading quantity with respect to the another one. So this is what a philosophy that we need to implement over here to solve this numerical. That will be the first technique. Second technique is that we can directly apply the concept of phasor diagram to solve this particular numerical. एक तो ऐसा है कि आप ये जो cos है इसको convert कर लो sin में, convert this cos into sin. So equation number 2 भी आपका sin में, equation 1 भी आपका sin में हो जाएगा, और फिर उसके बाद आप हर एक का फेजर डायग्राम ड्रॉ करो, और उसके हिसाब से फिर आप फाइंड आउट करो कि कौन किसको लीड कर रहा है और कितने एंगल से. दिस इज व्हाट एनालिटिकल टेक्निक. बट हम ये अप्लाई नहीं करेंगे, हम अप्लाई करेंगे कौन सा टेक्निक, फेजर डायग्राम का, क्योंकि हमने अभी स्टडी किया है कि व्हाट एग्जैक्टली फेजर इज एंड हाउ टू ड्रॉ फेजर फॉर एनी set of mathematical equations which are known to us. So how to solve this numerical directly by phasor diagram? Now see here, first of all I'm going to draw the structure for this. This is going to be the structure. Now on this structure we need to indicate two cosine functions, or you can say two trigonometric functions simultaneously, because one we have cos component which is cos omega t, and another we have sine component which is nothing but sine of omega t. So what I'm going to take, I'm going to take the cos component as a reference axis. So here I'm going to take cos of omega t. The moment I take cos omega t on the reference axis, or you can say plus cos omega t on the reference axis, plus sine omega t has to be on this particular axis. That means on the vertical axis, that too on the downward direction. Now you tell me why, what is the reason behind this? So I need to take here as plus sine of omega t. Now you tell me what is the reason behind this. The answer is very simple. See here, if you see the variation of cosine function and sine function, cos function or sine function, so this waveform indicates sine, and it start from 0 degree, and this waveform indicate cos. like this. Now if you project this on the backward side, it is going to be like this. So if you see, it is very clear that the cos function, or you can say cos omega t function, is going to lead the sine function. Why? Because from this graph it is very clear that sine component is going to appear at t equals to 0 or theta equals to 0 degree, but the cos function is started as theta equals to what? Minus 90 degree. Or this minus 90 corresponds to how much duration of time? I told you that 360 is 20, so 180 is 10, so 90 is going to be 5. That means 5 मिलीसेकंड पहले ही आपका कॉस फंक्शन पिक्चर में आएगा. सी 5 मिलीसेकंड पहले ही एक्चुअली आपका जो कॉस फंक्शन है टी इक्वल्स टू -90 डिग्री, या फिर आप बोल सकते हो कि यार 5 मिलीसेकंड पहले ही आपका कॉस आया, और जब ये 90 ये 0 पे पहुंचेगा तब आपका साइन पिक्चर में आएगा. दैट मीन्स आपका जो कॉस फंक्शन है बाय डिफॉल्ट लीड करेगा आपके साइन फंक्शन को बाय एन एंगल ऑफ 90, या फिर आप बोल सकते हो कि आपका जो साइन फंक्शन है वो आपके कॉस फंक्शन को लैग करेगा बाय एन एंगल ऑफ 90. And same logic I have represented over here. If you take cos function as a reference, so sine function is going to lag. See, is going to lag the cos function by an angle of 90. Because it is going to lag, that's why we need to indicate that in clockwise sense. That's why here if we have 0, so this is going to be minus 90. Now I hope this point is clear to everyone. Why I have represented this plus sine 90 in the downward direction. Why not in the upward direction? So this is very important. You may inverse this position. You may take this sine omega t as a reference. Now if you take sine omega t as a reference, for example, if you take plus sine omega t as a reference, so with respect to sine, cos is going to lead. So here this point is going to be plus cos of omega t, because it is going to lead the sine by 90 degree. This is very important. So it depends upon you which quantity you want to take as a reference. You may take cos omega t as a reference, so with respect to that plus sign has to be downward, or if you take plus sine omega t as a reference, then plus cos omega t has to be in the upward sense. So once this is clear to you, now it is very simple to draw the phasor diagram for these quantities. Let me erase this. So on x-axis I have taken plus cos omega t as a reference, and then on y-axis plus sine omega t as a reference. So this is plus cos omega t. So here we need to take minus cos omega t, 180 degree exactly phase shift. If this is plus sine omega t, so this is going to be minus sine of omega t. This is very important. Now why I have indicated over here, that is again just to sense whether the magnitude of that quantity is in positive sense or it is in negative sense. So here this is going to be plus cos, so this is going to be minus cos. If this is plus sine, this is going to be minus sine. Now let us try to indicate these quantities one by one. So first quantity is v1, which is going to be minus 10 of cos omega t. Now see here, if you take this as v1 going to be minus 10 into cos of omega t. If you focus on this only, so here this minus sign is going to assign with cos omega t. So minus cos omega t is something over here. This is very important. Now minus cos omega t, and that to the magnitude is 10. So this 10 we need to indicate corresponding to the length of the phasor, and then we have the concept of phase, and the phase is plus 50 degree. So plus means what? It is in anti-clockwise sense. Anti-clockwise sense means what? It with respect to this reference. But we need to take this as a reference because the magnitude is minus 10 cos of omega t. So minus 10 cos omega t, or if you ignore this 10, so it is nothing but minus cos omega t. That's why we need to draw this phasor on minus cos omega t axis. So minus cos omega t axis is this, and then we need to indicate whether it is lag or whether it is going to be lead. So here this plus 90, that plus 50, that means it indicates that it is going to lead. Lead means anti-clockwise. So with respect to this axis, with respect to minus cos omega t axis, whatever the quantity which is going to lead, that has to be shown on the downward direction. Why? Because it is in anti-clockwise. And if the quantities are negative, that means clock, it has to show in the upward direction because it is in clockwise sense. So if you apply that logic somewhere over here, that means in first, second, third quadrant, we need to indicate this V1. So here we need to indicate V1. So this is going to be the V1. V1, and V1 is going to lead. That's why it has to indicate in the anti-clockwise sense. And by what angle it is going to lead? It is going to lead by plus 50 degree. This is very, very important. I hope this is clear to everyone how we have represent this V1 on this phasor diagram. In the same way, let us try to see V2. Now this V2 is plus 12 sine omega t. So simply it is nothing but plus sine of omega t. Now plus sine omega t is on the downward direction. This is plus sine omega t. And let us try to focus on this phase angle. Phase angle is minus 10. Minus 10 means with respect to this reference axis, it has to be on clockwise. So clockwise sense, we need to indicate minus 10 degree. So here, somewhere over here, we are having the voltage V2, which is going to lag the reference axis of sine omega t, that is plus sine omega t, by an angle of 10 degree. I hope this is clear to everyone how we have drawn these two phasors on this phasor diagram by taking the reference as cos omega t minus cos omega t, plus sine omega t and minus sine omega t. Now it is very simple. Now see here. Here we have two phasors. First one is V1 and second one is V2. First V1 is going to be available at the leading with respect to minus cos omega t, and the magnitude is 10 volt. In the same way, V2 is going to available with respect to plus sine omega t in the clockwise sense because it is going to lag by an angle of 10 degree. Now our objective is to find out or check out of these two quantity which is going to be a leading quantity. Now see here, if you take this as a reference, now out of these two quantity, which is going to be available at the extreme anti-clockwise sense? So here this is available at anti-clockwise sense, that is V1 by an angle of 50 degree, and with respect to minus cos omega t, this is again going to be available at anti-clockwise sense. That is very important. So if you compare V1 and V2, I can say that V2 is available at most anti-clockwise sense with respect to V1, and I told you that the quantity is available at the extreme anti-clockwise sense is going to lead the previous one. So I can write here as V2 is going to lead V1. This is very important. And by what angle it is going to lead? So this is what the answer is. Here we have to find this angle. Now see, this entire is 90, out of which 50 gone over here, then 10 gone over here. So 50 plus 10, that is 60, 90 minus 60, this angle is going to be what? 30 degree. So I can write here as V2 lead V1 by an angle of 30 degree. This is very important. Why? Because this V2 is available in the anti-clockwise sense with respect to V1. See, anti-clockwise sense. And the quantity which is available in the anti-clockwise sense, that we can treat as a leading quantity. That is very important. So V2 lead V1 by an angle of 90 degree. Or I can treat this as V1 lag V2 by an angle of 90 degree. Both are the same thing. V2 V1 को लीड करता है 90 डिग्री से, इसी का मतलब है कि आपका V1 V2 को लैग करता है by an angle of 90 degree. So in this way you can solve this numerical. This question was, I think, asked in previous year GATE exam for electrical engineering domain. So this is what the concept is, to solve this numerical directly by applying the concept of phasor diagram. You may solve this particular numerical by applying the concept of analytical approach, where what you need to do, either you need to convert this cos into sine, or you can convert this sine into cos by applying that trigonometric formula, then draw the phasor diagram corresponding to each of the quantity on the phasor axis, and then try to apply this logic, that which one is going to be the extreme leading, which one is going to be the extreme lagging, and then based on that you need to find out the phase difference between V1 and V2 and try to find out that which is going to be lead and which is going to be lag. So final answer is, in this particular case, V2 lead V1 by an angle of 90 degree. Let me give you an homework, and your objective is to find out the relationship between the two quantities which are known to us. And the homework is something like this. Here we have two quantity. I1 is -4 into sine of 377t plus 25 degree, or you can say 25 degree. Let me erase this. This is 25 degree. 25 degree, and I2 is going to be plus 5 into cos of 377t, then minus 40 degree. And your objective is to find out, number one, which one is going to lead, or which is the leading quantity, which is the leading quantity. And second thing is by what angle, that means what is the difference between phase with respect to each other, that means what is the value of phase difference. So this you have to find out. You have two alternating quantity represented by equations I1 I2, where I1 is -4 into sine of 377t plus 25 degree, and I2 is plus 5 into cos 377t minus 40 degree. First you need to find out of these two which one is going to lead, and second thing is that by what angle that quantity is going to lead the other one. Let us try to find out this. And in the next lecture we will discuss the solution for this, and then we will continue with our course. Basically first we will discuss the concept of three phase, what exactly three phase is, what are the different possible conditions where we can connect the loads in three phase configuration, what is the meaning of star, what is the meaning of delta. Suppose if you have star, how to convert that into a corresponding delta, if you have delta, how to convert that into corresponding star. And then we are also going to discuss the basic features, that means in case of star combination, what is the relationship between line voltage, phase voltage, line current, phase current, and the same thing we are going to discuss in case of delta. And at the last we are also going to have the phasor representations for a three phase quantity. Thank you.